We have seen in some detail the spot size converter example to learn about the capability of the EME solver. Here are some other application examples suited for EME simulations. Here's a simple MMI coupler. Ideally, you would want to achieve a 50-50 power split between the two output ports. You can vary the multi-mode region to optimize the transmission. This is an MMI with tapers. The design goal here is to vary the taper widths to optimize the transmission. Since the parameter involved is not the length, you need to use the standard sweep tool in the Optimizations and Sweeps window. EME can also be very useful in designing devices for polarization control. In this polarization converter example, you can sweep the taper length to optimize the conversion efficiency from the TE1 input mode to the TM0 output mode. Similarly, you can use EME to simulate polarization rotators, as shown in this example. You can vary the rotator length and characterize the TE-TM fraction as a function of length. You can also simulate devices with periodic structures very efficiently in EME. In this periodic grating example, many periods are required to achieve a transmission with a distinctive stop band. However, in EME, you only need to include a single period in the simulation by using the periodicity feature. Since EME is a frequency domain simulation, you can get the result at a single frequency. If you want to characterize the transmission as a function of wavelength, you need to use the sweep in the Optimizations and Sweeps window. This Bragg waveguide grating example is very similar to the previous fiber Bragg grating, but it demonstrates a clever trick of sweeping the group spans of the grating instead of sweeping the wavelength to obtain the full transmission spectrum as a function of wavelength. This makes the simulation very fast, since changing the length in EME does not require rerunning the simulation, while the wavelength sweep requires a new simulation for each wavelength point. For a detailed explanation about this approach, please see the link below.